September 2015 before joining Vidyasagar University as head of the department and chairman of DST-FIST program, also the deputy coordinator of UGC-SAP in that institute. And he has joined Vidyasagar University as associate professor in October 2015. And he served here as a head of the department during 2017 to 2019. Also, he has visited several institutes in India and abroad. He is a member of, selected as a member of International Exchange Program of Indian National Science Academy, INSA, the very prestigious organization in our country, and Chinese Academy of Science, CAS, in 2012. And then CAS Visiting Research Fellow in 2014. Professor Maiti was selected as a visiting associate of the Institute of Mathematical Sciences, Chennai, the very prestigious Institute of Mathematics in our country, during 2016 to 19. He also availed 4 times visiting research fellow from CTS, IIT Kharagpur. He visited University of Sheffield, England in 2005. ETH Zurich, Switzerland in 2007. And Canada in 2011. Academy of Mathematics and System Science, CES, Beijing in 2014 and 2012 for conference and research work. He has completed 2 research projects funded by DST, New Delhi. He is principal investigator of DST-FIST in our department, present department. He has produced 2 PhDs, have been from this department, and Bits Pilani. He published 30 research papers. All papers are published in high quality journal, that is SCI journals. And he is basically expert in computational fluid dynamics. Computational fluid dynamics has a lot of practical application in science. He delivered more than 30 invited lecture in India and abroad. He received 2 times full funding from NBHM for attending conferences. He is a live member of Indian Science Congress Association, Indian Mathematical Science, Indian Society of Theoretical and Applied Mathematics, Calcutta Mathematical Society, and Indian Society of Industrial and Applied Mathematics. So this is the academic background of our speaker, Professor Dilip Kumar Maiti. Now today he'll talk about the basically the history of mathematics. I think it will be understandable for every person. I think he will talk about in that particular direction and very simple way. I think it is a very interesting topics for the participants. So now I request today's speaker, Professor Dilip Kumar Maiti, to deliver his talk.
Thank you, sir. Thank you, in fact, Professor Pal, and in fact, my sir also, who taught me in M.Sc. And first of all, it is visible. The slide is visible to all.
Yeah, but you need to maximize it and go on presentation. Yeah, we can see it.
But this is the presentation mode only.
Yeah, we are seeing it. It is roll of magic. It's yellow in color. Presentation Dilip Maiti. We can see it.
Yeah. Okay. And then next, thanks. I must thank Professor Panda for giving this opportunity. And really, this platform, I deliver many lectures since 2001 when I started my PhD. But this audience is something different. I know. In fact, in front of mathematics community, whenever we talk, we say that is heterogeneous. Now you think, what heterogeneous group is this now? When I received call from Professor Panda, and I was thinking which topic I should take so that my esteemed colleague from, Hindi, Sanskrit, Bangla, arts, all apart from my science colleague, how can I attract them? or how can make this I can title so popular that others can come and enjoy. So with my best effort, I have tried to prepare the slide so that anyone can, anyone in the sense my students, and then my colleagues and friends, they can enjoy the lecture. And I make this popular as possible. And mainly, the role of mathematics to daily uses and uncovering the nature of physical reality and epidemiology. If you see, first of all, the two-part role of mathematics to daily uses, it has many things. Probably what I'll be doing today in a sea, I shall simply drop a water, or I shall take a drop of water, other way around. There are so many things. So it is stipulated time. I shall try to cover as much as possible. And again, and mostly I shall discuss informal mathematics or non-theoretical mathematics. You don't need to, apply your mind for this axiom, theorem, proof. I am not going that way. That will be only daily use of mathematics, history of mathematics. In that way, I shall cover the lecture. And the second part, I shall try my area only to show you how mathematician can attack the problem of physical reality. And then in public health, how mathematician can help. Also, I have some few slides on that also. So the arrangement of the talk, see, so first I shall start by, short biography, some influential mathematician. Then what is mathematics? What is mathematics? The answer is not so easy, but still I shall try. Daily use of mathematics and some beauty of mathematics. Very interesting, funny. That also I shall show you to attract your mind. And then the second part, role of mathematics in present global crisis. Some of them I shall state only. And role to uncovering the nature of physical reality. Then finally, I shall conclude this talk by showing some slide on mathematical modeling on epidemiology or public health, the present crisis, which what we are seeing. So, first, let me start with very famous mathematician, Pythagoras, from 570 to 495 BC. I mean, it's from today around 2,500 years back. The famous mathematician Pythagoras, who have given the Pythagoras theorem, which is in the school children across the world. Very famous. I shall come with some of the other observations later. Now, as an Indian, I am very proud with this first. Aryabhatta. Aryabhatta, that is AD 476 to 550. He is an Indian mathematician. So he covered arithmetic, algebra, trigonometry, spherical trigonometry, quadratic equation, sum of power series. That was his, sum of the algebra or the place value system. Let me come to the next slide. In fact, India's first satellite in 1975, named after Aryabhatta during Indira Gandhi Prime Ministership. And IFRA, he's one of the authors on, this origin of, the origin of the zero. So he argued that Aryabhatta was familiar with the numerical symbol. Numerical symbol means 1, 2, 3, 4, and 0. And he knew the place value system. Place value system means how to place the numericals to represent a number. And he wrote, knowledge of zero was implicit in Aryabhatta place value system as a placeholder for power of 10. He used basically, 1, 0, 1, 2, 3, up to 25. And then 25, then he used 30, then 40, 50, 60, 70, 80, 90, 100. There are 33 consonants. With the help of those, he tried or he expressed a very big number, even 10 to the power 8 number also, he has expressed. And surprise, you'll know, I gave an approximation to the pi to those dates with some, some formula that I'm not going to. Now, next, let us come, Brahmagupta. I'm really, and just after Aryabhatta, he's born. Yeah? You see, Aryabhatta 550, and then he 598 to 668. And, around 628, he was the first, to formalize the arithmetic operation using zero. Arithmetic operation means addition, subtraction, multiplication, clear? Using zero. If you subtract two equal number, that will be zero. And in fact, this information, it was not easy to get it, but I searched some of the in the net, and the Robert Cullen, he is one of the also author in the Oxford University Press book. There, he expressed that around 658 AD, he was the first to formalize the arithmetic operation using zero. And in fact, it is known as also Indian zero. I'm proud to say this zero, also known as the numerical zero. One can also say the Indian zero. And people say he is one of the greatest invention in human history. You see the computer, this is based on only zero. And this, it was said by Peter Robert. He is also one of the author of books regarding this zero invention or history of zero. He stated that mathematical zero or sunya in Sanskrit may have arisen from the contemporaneous philosophy of emptiness or shunyata. Shunyata or emptiness. From there, probably it was originated. That was his observation. He is the secretary, and Peter Gold is the secretary of Zero Origin India Foundation, which its foundation is based in Netherlands. So, Brahmagupta very well defined addition, subtraction, multiplication using zero. He did very well. But unfortunately, he did a mistake while dividing by zero. He wrote the 0 by 0 is 0. He took the numerator 0 role, but denominator 0, that was a very blunder mistake by him. And for that, you have to wait up to Sir Isaac Newton and Leibniz, who have rectified this formula. And you see, what is the, realized from Newton? See, 2 by 3. हमारा माने की बुझी 2 by 3 means 3 divided 2 out of 3. So how many non-existent apple go into 2 apple means 2 by 0. 2 by 0 means 0 apple you are giving 2. So that's what, how many non-existent apple go into 2 apple. From this, from Jala University, the very oldest university in America, in their history of zero, I show they have stated in that way, and that was the observation from Newton, and from there we have rectified the division by zero arithmetic rule as what we see now. Now let us come to the very famous mathematician, Sir Isaac Newton. He is also a great physician, but from a mathematician, if we see, there are so many contributions from Sir Isaac Newton that I shall come one by one. In the field of Newton mechanics, first principle, second principle, third principle, clear, and this calculus. As we see the calculus now, that is because of this Newton only. And Newton attributed the discovery of the law of universal gravitation to Pythagoras. Now, very famous mathematician, Leibniz, 1646 to 1716, he is also credited along with the Newton calculus. In fact, there is a controversy among who invented calculus, Leibniz or Newton. Newton actually wrote some, calculus. He shared his notes with a friend of Royal Society, but by that time Leibniz published, and Newton got angry. He said that is stolen from his note. But finally, after very long years, it is observed they both of them invented in a similar duration, but differential equation, started from, by Newton, and integration from Leibniz, and they have different way they have invented the calculus. Now, Albert Einstein, though he is not a very good mathematician as of now, he is more on physicist, but he also initially started his career with mathematics at Zurich, and I am also happy to say that I have visited this university, in 2007 from some conference. Now, another great mathematician of India, the Srinivasa Ramanujan. Only 32 years he was in the world. With that, he was very ill, very poor. Apart from all those, still he invented 3900 result, mostly identity equation. Many are completely Lobin, origin, and highly unconventional. And in 2011, on his 125th anniversary of his birth, our Indian government declared 22nd December is the birthday of Srinivasa Ramanujan. And that day, in India, since 2011, is celebrating as a, National Mathematics Day. And in the year 2012, it was known as, National Mathematics Year. And our present department, Mathematics department, we have also started celebrating this National Mathematics Day every year. Now, let us, there are so many mathematics. I am not going to, I have not taken the, all of them, but very few of them, which I feel that I can speak probably comfortably, or I know them, that we have selected and I have stated in front of you. Now, mathematics. There are many I would say main conception. Math is hard. Math only coding. Math is abstract and boring. Only theory, proof, axiom. Math has nothing to do with real life. The very common statement. And math is a set of rule and formula that someone has invented, and students feel that is their duty to memorize all those steps, and they have to compute and get some score. And also probably during their teaching life, the way they learn mathematics, they feel that probably I have to remember and all those things, and I shall get some job, and my employer sometimes come, hey, hello, tell me what is the formula of that some sin x into cos x, or someone asks me, tell me the derivative of some complicated function. It's not like that. There is no such employer. Rather, in fact, with this means concept, I know there are many students, they usually they don't take maths as in that way. And as my understanding, as per my little knowledge, I can tell, you see, the maximum teaching post could be lying in the mathematics department. Everywhere. If anyone open any institute in engineering, at least apart from their core, civil and computer, whatever they open, they have to first introduce, they need to hire at least a single mathematics teacher. Without that, they cannot run the basic courses of mathematics, which they need in engineering also. And there are many other software jobs also. That I know. And let me tell you very interesting story. Math is in the gene of every individual. It I mean Bangla bol. Very interesting. I saw actually in WhatsApp 2 days back. Two mathematicians, they are arguing. Say person X, he's saying mathematician X. He say mathematics is not for all. But why? You are saying no, mathematics is gene in everybody. Then they are arguing with a different argument. Actually, I mean, matal, so we call it actually mod code, mod khai. Don't take it the other way. So the person was coming. He was not in the general state as we see, who take more and more, beyond their range. Then X person, okay, let him ask whether he know mathematics or no. Why? Then okay, you ask him. Then X asking that, do you know who is the bigger one, 2/3 or 3/2? He confused with that mind state. And if someone asks 2/3, 3/2, which is bigger one, he confused. Then X said, hey, see, oh, jani na mathematics ta. So what maths hoy na? Then why tell? Okay, let me ask. তখন ওকে কোশ্চেন করলো, এই same question, he was thrown the question in a different way, different pedagogy. ওরা হলো কি, দু প্যাক মদ তিনজনকে ভাগ করে খাওয়া ভালো না 3 প্যাক মদ দুজন ভাগ করে খাওয়া ভালো? He was laughing and he gave the answer, correct answer. So that basically the which way you are approaching the mathematics. Mathematics is with everyone. I can tell you some example. I shall talk about not the mathematics which we study, who did or who are doing honors or M.Sc. The mathematics I shall be talking with everyone, which is the informal mathematics, non-theoretical mathematics. So that's what my next is. What is mathematics? It's a very difficult question. Very difficult question, because with that question, I mean, it not be easy to come to a very final conclusion. What is mathematics? But still, I shall come and let us come from the very common high school mathematics or image, concept mathematics. Trigonometry. That we have studied the triangle properties, right angle triangle, there are so many properties. And you have studied geometry, circle, rectangle, square, and that properties. And algebra, that also is a number and their arithmetic operation, manipulating them with a different symbol. So that is the algebra that we have. I think in class 10, everybody has studied mathematics and class 2. And then step by step, those who have got interest, they come to the mathematics, formal mathematics. And then calculus, the derivative and integration in one variable, mostly one variable, and not the two variable, and some probability, mean, median, mode, and some other topics depending upon the board that I am not. So that's what there is a range of view among the mathematician and philosopher as to the exact scope and formal definition of mathematics. It's described in a lot of different ways depending on your perspective. In fact, there is a book, What is Mathematics? Of a very great mathematician, Courant and Robin in USA. Courant is very famous mathematician. They published 1941. But as for this author, these are the author basically, they have published one paper in the mathematical conference proceedings, international mathematics conference. They say she doesn't answer the question, what is mathematics? Nevertheless, I shall try only some very interesting way. I shall try to some mathematics. What is that? In ancient time of Egypt, if you see, they defined the science, mathematical science, which deals with the logic, not real logic, of shape, different quantity, and how do we arrange them? In fact, with their concept, they could manage to build the pyramids. Now, if I say the award, basically, if I see, I have searched it, award come from Greek word. These are the symbol of mathematics. Mu, alpha, theta, eta, mu, alpha. Basically, the mathema. This come means the mathema. Meaning is, if you see in the dictionary, they'll say mathema, science, knowledge, or learning. Science, knowledge, or learning. And this sometimes we call the maths or math. And if you see the Wikipedia definition, that say mathematics is the abstract study of topics such as quantity. Quantity means there are different number, actually number, and how do you multiply them, subtract them, or there are different operation. And also the structure, also algebra. Algebra is also you'll have the sets you have. How do you apply the operations? This is a very formal definition. Probably all of you will not be interested or will not be able to get it. So I'm not going in details in that definition. And the space, geometry. Space, basically the mathematics has come from mainly from astronomer. If you see the Pythagoras, Aryabhatta, Brahmagupta, they are astronomers that come from only the astronomy geometry point of view. And then change means rate of change, calculus, analysis, what is the change, how it is happening. If I have to find the velocity while I'm driving, how can I take the turn, how much speed should be. So that lies in the analysis or calculus. And the definition, if I see also, through the use of abstraction and logic, mathematics is developed from counting, calculation, measurement, and systematic study of shape and motion of physical object. Again, let me repeat this. The abstraction, very abstract way and very logical way, mathematics is developed from counting system, calculation, how to measure, and systematic study of shape and motion of physical object. Newtons and what I have shown the slide from there, you see how the mathematics have developed. You see, these are some of the sequence the mathematics has been developed. Now, what is the mathematics? It is the building block for everything in our daily life. Cooking also. If you see nowadays, I think many of you are making very tasty food. Items during this lockdown because maids are not allowed to inside house. So if you go to YouTube, you see some recipe, and there you see how much quantity. How do you mix it? See, quantity, how do you arrange them? This is basically abstract, sequencing. That basically concept hidden in your mind, that is mathematics. Even marketing, if you go to marketing, the people, Professor Rai today morning has saying, you should say something about the marketing. Marketing, if you go in the subji, those who sell subji or fish, very popular. Let me tell you one very good example. Few days back, Raja Bazar আমি গেলাম, যার কাছে মাছটা নিই আমি, সাথে আমি জ্যান্ত মাছ নিই। দেখলাম ওর কাছে মাছগুলো একটু আমি বেলা করে গেছিলাম একটু অন্য কাজ, দেখি মাছটা নেই, দেখি তো কি অবস্থা। ও মাছগুলো সাথে জ্যান্ত মাছগুলো 200 করে নেয়, যারা মেদিনীপুরে আমরা থাকি সাথে এটা স্ট্যান্ডার্ড রেট। ওই মাছটা 150 টাকা বললো। আমি কি ব্যাপার, 150 টাকা ঠিক আছে। ও 150 টাকা বলে সংসার স্যার খুব ভালো মাছ, খারাপ বলে দিয়ে দিবেন। ও মাছটা তুলে দিল, তুলে দিয়ে হলো কি 1 কেজি 400 একটু কম। আমি থিঙ্কিং করছি মাছটাকে নেবো কি নেবো না। বাই দ্যাট টাইম ও কি করলো কি, অলরেডি আমার একটা মাথা হলো কি একটু টাকাটা কম, 50 rupees কম। সেকেন্ড ও একটা আমাকে অ্যাটাক করলো কি 210 টাকা, আপনি 200 টাকা দিবেন। Before calculating the mathematics they applied, I was caught. আমি মাস্টার নিলাম, নিয়ে এসে দেখলাম মাস্টার একদমই খারাপ। So that is also mathematics. This is marketing math. There are so many examples, so many examples. Mobile devices, architecture, art. Art, you want to draw something, you have to decide how you divide, how, from where you start, how you make the curves. So this is mathematics. Money, engineering, medicine, sports you see. The আমরা যে ধোনির এটা আমরা বলি ধোনির কি জানি হেলিকপ্টার শট, ওটি ম্যাথামেটিক্স। মানে ওকে এমন একটা ফোর্স দিয়ে এমন একটা এতে মারতে হবে যে যাতে করে ওকে 6 পড়তে হবে। দ্যার সো মেনি এক্সাম্পলস in sports and medicine, CT scan, MRI, they use mathematics. Math is universal language. See, if I state in physical, if I state in English, that has to be translated to other language, those who don't know the English. But mathematics equation, those who know mathematics, they will understand 2 + 2 = 4. You don't need to translate to anywhere in the world. I'd say so mathematics is the universal language. Now, some insight to the mathematics by great scientists, what they feel what mathematics is. In the 17th century, Galileo, he stated, our universe is a grand book written in the language of mathematics. In the language of mathematics, our universe is written. And Newton he described God as a skill in mechanics and geometry. Skill in mechanics and geometry. Without that, probably the universe would have been impossible. As per this, the famous mathematician, their view, Pythagoras. Pythagoras believed that, and let me tell you some of the very, the information, mathematics, how it is related to the music. Pythagoras believed that the planet and star move according to the mathematical equation. That nowadays everybody, those who work in the cosmology or physics, they know. And thus it's resonant to produce an inaudible symphony of music. Inaudible symphony of music. That is come from the there. And Pythagoras, what he did, he was moving. And one day he heard that there is sound. হাতুড়ি দিয়ে কেউ মারছে, সেই সাউন্ডটা আসছে, ও কানে খুব সুন্দর লেগেছে। দেন হাতুড়ি যখন মারছে, ও তো ডিফারেন্ট ফোর্সে পড়ছে, ডিফারেন্ট জায়গায় পড়ছে, ডিফারেন্ট সাউন্ড হচ্ছে। উইথ দ্যাট হোয়াট হি ডিড, ওয়েন্ট টু দ্যাট there, and he observed that tune played when hammer struck was directly proportional to the size of the hammers. That is everybody know. If I take ছোট্ট একটা hammer দিয়ে আমি হাতুড়ি দিয়ে মারো একটা জায়গাতে, যে সাউন্ড হবে, if একটা বড় দিয়ে মারো, then you have the different sound. So he concluded that music was mathematical. Music what? In fact, during Middle Age, Pythagoras is actually known as, referred as founder of mathematics as well as music. Mathematics as well as music. The Kepler also inspired by mathematics, Pythagoras, and he believed that the motion of planet produces music. And then very, those who mathematician, at least they know Manjula Bhargav, and in mathematics we have the Nobel called actually Field Medal that is presented Indian International Congress on Mathematics. So in 2014, it was awarded. It was awarded to Manjula Bhargav, who is actually he born in Montreal, Canada, but their parents are from Jaipur. And he's very terrific. In fact, one of the professors from Princeton, he said he's a terrific musician who has reached a very high technical level. Technically, he was very sound. And Bhargav often turned to the tabla when he stuck on mathematics problem, and vice versa. He said when I go back, my mind has cleared. And he experienced playing tabla and doing mathematics research similarly. And he said, Indian classical music, basically he was exposed to Indian, and he was a very, familiar, or he was very exposed to this Indian classical music. He related the classical Indian classical music to the number theory research. Number theory is, very few of us in Ramanujan work number theory. And in India, really, this pure mathematics that under very few of us in India work in number theory. So he said it is very largely improvisational. Improvisational. I said it is similar to math. You have to put together a sequence of idea and then relate into you. In mathematics, in algebra, you see, you will have different number. What you do? Or say if you have some project, project of, say, building a house, how much it cost could be. So what you do? Window, different cost, door, different cost, cement, bali. তো যা যা আছে তাকে আমরা করি কি বিভিন্নভাবে তার রেসিপ্রোকাল দিয়ে আমরা তাদের করসপন্ডিং প্রাইস দিয়ে গুণ করে আমরা করি কি we come to a final amount. If you see the math involved, they are very sequential. But in that example what I give you, that sequence you can say that not going to change. But there are many things you will see in music. If I am not a feel music has some sequence. In number theory, you have to follow a very strict restriction or strict, the sequence. And he said, mathematics, music, and poetry together feel like a very complete experience. And all kind of creative thought come together when I think about all three. Okay, so in this mathematics, whatever I said, none of these are entirely wrong. But the same, this may not satisfy you. Some of them be satisfied, may not be satisfied. Because as I beginning said, it is very difficult question to answer what is mathematics. Now I shall come to the daily uses of mathematics. So there are many branches of mathematics which are applied to real life. So, let me cover very few of them: algebra, calculus, geometry, mechanics, statistics, commercial or financial mathematics. Some of the cases I shall try my best to tell you how these are used in daily life. The algebra, study of structure in formal definition. Study of structure. We have set, group, ring, field. There are so many technical terms in mathematics, and their relation, and then quantity. This word algebra in 9th century, Persian mathematician. This actually he is known as father of algebra. He is father of algebra, we say. So algebra is useful in daily life. See, the study of algebra help in logical thinking. Basically, in algebra, if you study the algebra, formal algebra, you will see there is very structural logics. That will help you to think and enable person to break down a problem first and then find a solution. In mathematics, always what I feel or what I tell my students, once the problem is given, you have to read each and every word. There is a hidden method for application. If I see how in daily life algebra uses, suppose we have to appoint a person for some domestic purpose. Okay, আমরা দুটো অপশন দেওয়া গেল। ওকে বললাম কি তোকে 25 টাকা ডেলি দেবো, আরেকটা বললাম কি ওকে 5 টাকা প্রথম দিন, তারপর থেকে তোকে 2 টাকা করে বাড়িয়ে যাওয়া হবে, 2 টাকা টু দ্য প্রিভিয়াস ডে টু ফর দ্য নেক্সট ডে, 5 টাকা 7 টাকা 9 টাকা এইভাবে করে করা হবে। So which one will be option for him? Which will be better for him? এই অপশন 2 প্রথমে আমরা যদি অনেককে যে বুদ্ধ বানানোর চেষ্টা করা যায়, সে কিন্তু যারা একদম মানে কি বলবো রিলিজিয়াস, তারা কিন্তু বুদ্ধ বনে যাবে, কারণ 25 টাকা শুনে ও কিন্তু প্রথম অপশনে নিয়ে নেবে। বাট সেকেন্ড অপশনে যে দেখা যায়, প্রথম অপশনে কি আছে, আমি 25 × 30 করলাম, 750 এলো। বাট অপশন 2টা কি হলো, কি 5, 7, 9 এভাবে 30 টার্মটা আসবে, টোটাল 30 টার্ম অ্যাড করে দেখা 1020 মানে এখানে পেতো 750 টাকা, এখানে পাচ্ছে 1020। So this mathematics slightly someone need to know, and probably those who are farmer or they are the lab, I mean the domestic worker, they may get to know, otherwise they will be caught by this. In, as I told you, that algebra uses in cooking, you see, these are the recipe, all these are in fact this depends on যে আমি এগুলো কিন্তু যখন যা হবে, আমি প্রথম দেখবো কি কি আমার লাগবে, আমাকে নেক্সট কি প্রসিডিওরটা কি, প্রসিডিওর, দ্যাট ইজ সিকোয়েন্স, দ্যাট ইজ স্ট্রাকচার, দ্যাট ইজ ম্যাথমেটিক্স, দ্যাট ইউ আর what mathematics hidden with you, that you are basically you are applying. And suppose you have in a dining table, you have guests, there may be some small children, there are very old people, and you have some item, you have to distribute it, you have to apply mathematics. তাকে কতটা দেব, কে কতটা খাবে, মিনিমাম ওয়েস্ট হবে, ম্যাক্সিমাম সবাইকে খাওয়াতে পারবো, there are so many things run in your mind, even catering system. আমরা কল্লোল্লাহকে যখন কোনো আমরা অর্ডার করি, কি করি আমরা, ও একটা রেট বললো, বেসিক গুলো বললো, তারপরে আমরা আইটেম গুলো একটা অ্যাড করি, ও কিন্তু একটা ওর প্রাইস আমরা অ্যাড করে চলে যায়। বাট ইফ ইউ সি হিজ ম্যাথমেটিক্স ভেরি স্ট্রং রাদার আস, বিকজ আমরা যতই আইটেম বাড়াবো, ওর ওই প্রথমে যে অপশনটাতে ওর একটা ধর মাংস, আমি শুধু মাংস ভাত করবো, যতটা মাংস ভাতে ধরলাম আমার 100 টাকা পার প্লেট, মাংসটা আমার যতটা লাগছে, ধর 15 কেজি লাগতো, আমি যখন ওখানে আমি আইটেম অ্যাড করে যাচ্ছি, ও কিন্তু প্রাইসটা প্রপোর্শনাল বাড়িয়ে যাচ্ছে। অ্যাট দ্য সেম টাইম ও কি করছে কি, ও 15 কেজি 15 কেজি কিন্তু ওর চিকেন লাগবে না, ও কিন্তু কমে দিচ্ছে, সেখান থেকে কিন্তু লাভ করছে। সো দিস আর ভেরি হিডেন ম্যাথমেটিক্স। ইন সামটাইমস হোয়াট দে ডু, ম্যানেজমেন্ট হোয়াট দে ডু, খাওয়ার আগে পকোড়া আর পুরো এটে দিয়ে আপনাকে সুন্দর খাইয়ে দিলে, তখন খিদা পেটে খুব পকোড়া খুব সুন্দর আমরা খেয়ে নিলাম, কিন্তু ওর ক্যালকুলেশন আছে ওখানে কম আইটেম কম কোয়ান্টিটি রেখেছে, ইন দ্যাট ওয়ে হি উইল বি বেনিফিটেড। সো দিস আর সাম ম্যাথমেটিক্স। Calculus is the modern world you see, that is fully based on the calculus. You have studied limit, derivative, integral, the infinite series. These are the formal definition of calculus. In fact, it's without use of calculus, road, bridge, tunnel would not safe as they are today. কারণ আমি সিম্পলি একটা কথা বলি, যখন আমরা ড্রাইভিং পুরো রেক্টাঙ্গুলো রেখে দিই, তাহলে কিন্তু কি করতে হয় আমাদের, কি হ্যাভ টু স্টপ অ্যান্ড টেক দ্য টার্ন। সো অ্যাকচুয়ালি কনসেপ্ট অফ কার্ভেচার অ্যান্ড টরশন, হোয়াট ইজ কার্ভেচার, এই যে কার্ভগুলোকে বলা হয় কার্ভেচার, কতটা আমার কার্ভে হতে হবে, আর টরশনটা হচ্ছে কি, হাউ মাচ ইউ টেক টুইস্ট ফ্রম আউট অফ দ্য প্লেন। যখন আমি মোটর বাইক বা স্কুটার আমি ড্রাইভিং করছি, when you are in a plain area, that is curvature, the curve. But once you are taking the road in hill, that is torsion. ওই কার্ভেচার কিন্তু এই যে কার্ভেচার সঙ্গে সেম হলে হবে না। ইভেন মোটরসাইকেল যারা আপনার দিকে সার্কাস দেখায়, দে অলসো ফলো ভেরি ওয়ান পার্টিকুলার পাথ, সাম পাথ অর দ্য ভেলোসিটি, so that there will not be any accident. So tunnel they use. So that is the mathematics, the calculus uses. And if you see the formally, it is physical science, actual science, computer science, statistics, engineering, economic, business, medicine, demography, and any other field where the problem can be mathematical model and optimal solution is here. Mathematical model, and I shall show you in most of the research that either people are doing analytically, experimentally, and computationally. And in the modern science, I work in computational fluid dynamics. I observe Those who are engineers, they're supposed to do experiment. But because of this calculus and this computer development, they are coming to the computational. In chemistry, physics, people are coming from experimental to theoretical science because of this calculus. The physics, that's what, related through calculus. And example of the mechanics is the Newton's second law. This is complete calculus. And in fact, calculus is born from there only, by the Newton only. I am not going to tell you the history, that shortage of time. And Maxwell, and I have the experience of, as I am visiting fellow IMSc, Chennai, theoretical chemistry, theoretical physics. Actually, the IMSc here, very renowned professor of physics are there. Though it is mathematics, but no, that is mainly theoretical. In fact, it was established by, I forgot the name of the founder of IMSc, but he was great physicist. They do, even biologists, computer, those who do theoretical computational study, they are in IMSc. Center for Theoretical Studies, IIT Kharagpur. There will see the many physicists, many electricians, they are working, and many mathematics M.Sc students, they are working there. In chemistry, I know my friend, my Pilani, are here also. Theoretical and computational chemistry, they are also using calculus. Biology, there is a growth rate bacteria and public epidemiology, that nowadays the coronavirus epidemiology, whatever prediction you are seeing, they are using calculus only. And the protein DNA, I have one of my close friend working in Pilani. He watched basically, and there is a computational laboratory in our there. He watched basically Professor Sivasi Chaudhary. He watched the in charge of the laboratory, computational. He worked biologist, but he worked in protein DNA interaction and modeling of RNA structure. Very hardcore mathematical computational.
Professor Maiti, could you please conclude within 5 minutes?
Okay. Nimic other prediction. And how much time have taken? Have taken notes? Oh.
It's already 45 minutes. Already 45 minutes.
Oh, sorry. So integration. So there are in geometry. Let me go first. The geometry. Geometry, to see architecture. This is very important. Unless they don't know geometry, they cannot, give you the plan of a building, which need to optimize space, room size, everything they have to put together and within that specified space. And this car, if you look at the car, there are many shapes. This is rectangular, this is circle, and this is 1/4 of sphere. These are the mathematics concept. In the morning, you see the rectangular shape of newspaper and throwing stone. If you see throw a ball, a sportsman, they have to put perfect, in such a way that should basketball have to come to that circle only. Okay, I think let me skip some of the things. These are median. So median mode. So average daily expenditure in a month of a family comes from the concept of mean. 15 people of different height are standing height-wise. Then middleman height is the median height. The concept from median only. A shopkeeper keep more stock of a particular type of shoe which has more sale. And that basically comes from the mode of statistics concept. Commercial or financial math nowadays is very popular and has getting more demand. There is you see the discount, simple discount, minimum purchase discount, buy one, get other one, the pair discount, pair set discount. There are many discounts. There is hidden mathematics. This arithmetic, that is also. Okay, these are the funny that I am not going to very 5, 6, 26 letter denoted and calculate hard work. Add the number algebra apply, it comes 98. Knowledge apply 96%, but attitude 100%. And in fact, any problem, Novel coronavirus So how all people and their government have been the estimation of the people who get might infected, how many of them, how many years it will continue. All these, it depends on mathematical modeling on epidemiology. I have some slides, I will not be able to show. There are, if you see market, many things are not available because of lockdown, because manufacture, transportation, inventory, all are affected. So that also some involve mathematics, and you need to have some, optimization technique to, regularize all this. So physical reality, one of the next part, probably I will not be able to finish comfortably. The only tell you, the Gauss told mathematics is the science of queen of science, because it was so successful to uncovering the nature of physical reality. So one of the cases is Newton's second law. From there, one equation is derived in Navier-Stokes equation, that is 1837. It is, as on today, this is $1 million open problem if anyone can solve analytically, but no one can solve, and it has a lot of application in the real world. Only we have to solve it by numerically. These are all computational. I work in this area. I work in this area. So this is vortex setting from a cylinder. This is mathematics. One is a branch is fluid mechanics, and under that this comes. Clear? These are the applications I'm not talking. And as I told, any scientific research can be brought into this line, 3 line, either experimental or analytical or numerical. Numerical experiment in virtual world, which involve mathematical modeling. What are the PD, partial differential equation involved? What are the boundary condition? Initial what must to provide, and then apply the suitable numerical technique to find the solution. Many engineers, many scientists, they're coming to this branch, leaving the experimental because of their cost and time in the experiment. And this is the small one slide, how to get the Navier-Stokes equation from simply the second law, Newton's second law, force equal to mass into acceleration. So mass acceleration is fine, but force, if you take a very small cube, and what are the force, body force, surface force, pressure force, whatever force applied there, one can calculate. In fact, in our syllabus, we teach them how to derive this Newton's, from Newton's second law, how to the Navier-Stokes equation come. That we teach in there. This is one of the form of the Navier-Stokes equation. And this, as I told, Clay Mathematics Institute, they have said this is $1 million open problem. And this is my study. These are some of the composition which made by my students and myself under one project, DST project. So this is the use of Newton's second law, or the Navier-Stokes equation. Mathematical modeling, as time is not there, simply I am telling you, this is simply susceptible, infected, recovery, and vaccination. It easily mathematically is shown that, and probably many of you are familiar with the reproduction number by this time. Reproduction number is the measure by which one can say whether this pandemic will be endemic, pandemic will continue, or that will come to end. So this vaccination strategy will definitely eradicate the pandemic. And there is a very good study, mathematical study. The mathematics involved. Clear, some people can be vaccinated, even before vaccination they may be infected. Clear, this is a natural, natural immunity, and this immunity comes from vaccination. So these are mathematical equation. One can easily explain or understand the mathematics here. And finally, so this one reproduction number must be less than 1, so that all solution converges to susceptible and vaccination. No infection. Infection will be vanished. Infection will be 0. And if you get than 1, infection will be there. That will be forever. Positive constant will be there. So there are special cases. As I think I have to stop. I have taken again more than 5 minutes. So these are also very. This method of modeling has been applied to a mimicking missiles with this data, and it is shown that R2, the reproduction number, can be made below 1 with the suitable vaccination strategy and suggests that disease eradication is valid and disease can be eliminated from some suitable vaccination strategy. So there nothing very difficult to conclude, but conclusion is maths are base of all our life, and we must teach children from an early age, not as an enemy, but as a daily and a familiar. It could be said that mathematics is fundamental in education of children because if you see, আমরা অ আ ক খ থেকে সঙ্গে 1 2 3 শিখেছিলাম 1 2 3 4 বা ABCD সঙ্গে সেপারেটলি আমরা কিন্তু শিখেছি 1 2 3. This is also one language. They must be taught in proper way with proper pedagogy, and in that math will teach them to analytical thinking, and analytical thinking develops the ability to investigate and know the truth about the world about us. Math is unavoidable. Without math, there would not be no science, no music, no art. Math is all around us in everything we do. These are references, and thank you your patience. And
thank you, Professor Maiti, for your very lucid and splendid presentation. Yeah, with the kind permission from the chair. With the kind permission from the chair. Professor Pal, with your kind permission. Yeah. Yes.
There are, first of all, I am thanks to the speaker for his nice introduction of the different areas of application of mathematics. But due to the lack of time, few questions are there in the chat box. So, Professor Maiti, you may see the questions in the chat box.
Maybe, yeah. First question was raised by Mr. Satyajit Mahata. Satyajit, are you there? He put a question, sir, did Aryabhatta invent zero?
Actually, that's what I also took some time to come to conclusion. In fact, if you see there is a no Aryabhatta, Brahmagupta invented zero, as for the the literature say. As for the literature say, I have gone to very good, some of the very good books, that statement that say it was Aryabhatta knew the zero. He used the zero for expressing number, but never used as a symbol or as a number. Okay, he took as a symbol, but not as a number. But Brahmagupta, he has taken or invented zero as a number, numeric value, with different, arithmetic operation. Only he did mistake by zero by zero. That was the only mistake.
And Dr. Prosenjit Acharya, he has a couple of questions. Dr. Acharya, Prosenjit.
I'm here.
Please unmute. And
yes.
Prosenjit.
Thank you, sir, for this informative lecture. I'm wondering that we could miss some of the important contribution from the Carl Friedrich Gauss and the Bayesian mathematics. Carl Friedrich Gaussian mathematics and Bayesian mathematics.
Okay.
Because we, as a researcher in the atmospheric science and land and atmospheric sciences, we need a lot of help, of this mathematics from Gaussian school of thought and Bayesian school of thought. So I think that if we could bring some lights on that would be better. And another question is that why the Lagrangian equations are so elegant in predicting the path of the cyclone?
Oh,
I know if this is this is out of the box.
There are many things.
I can give an outline about the Lagrange equation. Basically, the Lagrange equation is an extension of our Newton's equation, Newton's second law, basically. Right. And Newton's second law is applicable only for the one-dimensional problem, mainly containing single parameters, mainly, but it can be extended for few parameters. But Lagrangian method or Lagrangian equation is basically handled with several parameters. It also is second order differential equation. So it investigate or studied the motion of any particle or any similar kind of phenomena. So in cyclone, basically follows the path. So that path can be modeled as a Lagrangian equation. Okay. So it has some sources of energy. Okay. Sources of force, energy. Two types of energy are handled by the Lagrange equation. One is the kinetic energy, another is the potential energy. But in Newton laws, we are using only forces, sources of forces. But Lagrangian equation, the advantage is only the energy is sufficient to formulate that equation containing multiple parameters. You know, the cyclone depends on different parameters. You know more than me. No, you are from the geography department. You are working on atmosphere. So a lot of parameters are there in the cyclonic situation or phenomenon. So for this reason, Lagrangian is the one of the best way to handle such situation. Okay. So as per my knowledge, I know that, but I have no much idea about the cyclonic motion. But I have an idea about the Lagrangian motion because it is developed from the mechanics. And another question you have been asked me the Gaussian and Bayesian mathematics. Basically, these are the statistical mathematics. Gaussian and Bayesian are the statistical things. When the uncertainties are there,
Right.
in every field, any kind of field, even our COVID-19 situation, we are using the probabilistic model, uncertain model. So when the uncertainties are there, then we are using the Gaussian. Gaussian is very normal things, called the normal distribution. So normal phenomena, normal situation can be modeled by the Gaussian. It may have the bad thing, good thing like that. Mission is different types. So a lot of different distributions are there depending on the situation. We are using different statistical models. Basically, these are the statistical model, uncertain model. So this is the thing. Another question, Dr. Maiti. So is there any role of Vedic mathematics in shaping modern day mathematics?
The question was raised by Dr. Nandini Ghosh. Maybe Dr. Nandini Ghosh we can ask. Nandini, are you there?
Hello? Yes, sir, I'm there.
Nandini.
Hello, sir. It is a very informative lecture and I enjoyed it a lot. Just one question we have many things. We heard about many things about Vedic mathematics but don't have different knowledge about it. So is it really important in shaping modern mathematics or it has any role?
What Vedic mathematics? Actually, I am also not much aware of this Vedic mathematics, frankly speaking. Vedic mathematics I had also, but I have to go through it.
So I have to I can say a few words about Vedic mathematics in modern day situation. Really see that the Vedic mathematics is a very old concept, but it has very interesting direction. Basically, in Vedic mathematics, we are using some shortcut methods. This is the main things, and these are comes from our Vedas. So lot of shortcut methods are there in Vedic mathematics, but if we use that shortcut method in our modern mathematics, then the computational time will reduce. But we are not bothering very much because nowadays the computers are available, very high-speed computers are available. So we the people are using the conventional mathematics or the new development of the mathematics. But if you use appropriately the Vedic mathematics, then again the computational speed will be reduced. Okay, so this is the main overview. I have no much more idea about the Vedic mathematics, but this is the basic concept we are using. Very shortcut concept.
Thank you.
Another question is Ramesh Dash is written here. The Lagrange equation can be optimized. Okay, in economics, it is good observation. Lagrange equation. There are different type of Lagrange equation. Lagrange is a very great mathematics. One of the topmost mathematics. Lagrange, Euler's, D'Alembert, etc. So Lagrange equation, which is used to model the cyclonic motion, that one equation. But Lagrange equation, which is used to optimize any economical mob problems or any other kind of problems, that is another equation. There are two different equations. So Lagrange equation is also there for other type of problems. So Lagrangian equation, there are a lot of different form, different applications like that. So I think
Dr. Maiti, Dr. Prosenjit Acharya, you wanted to comment something else?
Yes. A couple of months back, when I and Professor Amir Panda had a conversation that how to bring these conventional science practice into citizen science, right? So this concept of practicing the hardcore science into citizen science has a long traditions in Western world. So take the examples of Stanford, MIT, Harvard, Oxford, and other European best universities. They have their citizen science forum, right? Translating the language of the core science into the language of laymen, so that people can understand. So when the non-mathematician students, not mathematical students, would like to understand and learn mathematics, what is your suggestion? Because I, in my classroom, has faced a lot of questions that, sir, whenever you started lecturing on statistics, you are just like you are doing kind of a core mathematicians. So it seems that it's pretty much difficult for me to synthesize everything within 50 minutes of class to give them enough understanding. So what is your suggestions that if students want to learn mathematics based on this national education policy, if a students from in the graduations wants to learn mathematics who has not have a mathematics background, how do that students start with?
No, actually, that very, as I told, mathematics 2 plus 2, as I told, is a universal language. So don't need to convert to other language. The problem is, say, if I give you one equation, differential equation, if I write it in front of the person who don't know what is the derivative, then the writing of the differential equation is meaningless. So first you have to go back the derivative, and you have to tell them what is equation, and probably you can write the differential equation. Because the speaking, that is the language, whatever communication you want to do that different issue. But math language, that involves some technical theoretical mathematics that one should know. Otherwise, that for them that will be something like a symbol or just one of the people actor
I guess that is there some methods, some techniques that could be used to take out the fears of mathematics from the student's mind?
That's what?
Is there some techniques, something which take out the fears of mathematics from the student's mind?
Fears of, I could not follow.
No, I mean, সাধারণ মানুষের অঙ্ক সম্বন্ধে একটা ভীতি আছে, খুব সহজ ভাষায়। আমি ফিজিক্যাল কেমিস্ট্রির ছাত্র হয়েও আমি বড় বড় ইকুয়েশন ডিরাইভ করতে ভয় পাই। But I believe in the language of mathematics. Means what Dr. Acharya wanted to say, instead of deriving a huge equation across the blackboard, can we generate a general awareness on the language of mathematics?
Right.
This is what you wanted to convey.
Yes. Professor Paul also will add with me. First of all, we have to see who is the audience. Once you are teacher.
No, I am saying one word. So, from the school standard, we see that the mathematics is not a simple thing. No. So we can remove the fear from mathematics. It is only the we can say what is the responsibility of the school teacher. If anybody, any teacher can teach the mathematics in a lucid way by giving the some example, real example, then or by solving a simple problem. So it is the school standard problems actually. When we are teaching the undergraduate or postgraduate student, then we have to derive some equations. And what is the main problem? The students who are not from the pure science discipline. Basically, I am talking about my one experience. I am taking the class of biological sciences, where for statistics. So one day I have written A plus B by C. Just I have written A plus B by C. The formula is there, mathematical formula is here to calculate some statistical parameter, very simple parameters that is say media. So I have given some home. I am just illustrated how we can calculate the median and given some example for the student homework. Actually, I have given homework. But one next day, the student calculated solved all the problems and find out the medians or any other parameters. But he has spent a lot of times, but all the results are incorrect because he has no idea about A plus B by C. He just calculate using the formula A plus B by C, means A plus B divided by C. But the formula I have clearly written A plus B by C. So there is another problem for the biological students. I am taking from my experience, not for the all students. A lot of students knows the mathematics, but another problem is x power 2 and x suffix 2. This is the another problem for PG students. So I can see that I can tell you, if you start the statistics, you just give the applications of your parameters. What is the meaning of mean, standard deviation, then median, etc. Just explain its significance. And you nowadays there are a lot of software are there, so you can use the software to find out that thing. If you calculate the parameters, so median, mean, etc. for given data, then the student will leave the class or they will be motivated to attend your class. But if you explain the meaning, significance, and just use the statistical parameter, then they will, I think they get some interest. But I am talking one interesting thing. Professor Panda is there from chemistry discipline. Just I am working on a particular subject called the graph theory. You know, the isomorphism is there, no? The chemistry people are using isomorphism. I am just using Bengali to explain this one. So we know the compound chemistry, methane, ethane, propane, like this. CN is 2n plus 2. No, that paraffin groups. So CN H 2n plus 2. This is the very important chemical compound. So actually, the Na different value আমরা substitute করি n 1, 2, 3, 4, etc. Then we have methane, ethane, propane, butane, like that. Just like that. So there is a question, big question: how many different isomorphic compounds can have for a different n? No, মানে কত ডিফারেন্ট ভাবে আমরা সেই প্যারাফিন ফর গিভেন n ধরে n যদি 5 হয় তাহলে কত ডিফারেন্ট আইসোমরফিক কম্পাউন্ড আমরা পেতে পারি। তো এইটাকে স্টাডি করা হয়েছিল, মানে পুরো কেমিক্যাল কম্পাউন্ডকে আমরা একটা স্ট্রাকচার রিপ্রেজেন্ট করতে পারি, ম্যাথমেটিক্যাল মডেল বলা হয় গ্রাফ থিওরি। সেই গ্রাফের সাহায্যে আমরা ধরুন প্রত্যেকটা প্যারাফিনকে আমরা রিপ্রেজেন্ট করতে পারি ফর এনি এন, and then we can use an algorithm, একটা মেথড আছে to check the different isomorphism, to draw the different kinds of compounds for different n. তো ডিফারেন্ট এন এর জন্য আমরা কি কি পসিবল কম্পাউন্ড হতে পারে আমরা লিখতে পারি, এবং তারা সিমিলার কিনা ফর লার্জ এন। যদি এন 100 হয়ে যায় তাহলে কি হবে, ডিফারেন্ট শেপে আমরা C100 H 202 সেটাকে আমরা রিপ্রেজেন্ট করতে পারি। তার বিভিন্ন রকম ফর্ম থাকে, কিন্তু কতগুলো ডিফারেন্ট আমরা আইসোমরফিক কম্পাউন্ড পেতে পারি। সেটা কিন্তু ম্যাথমেটিক্সের একটা বিশাল ভূমিকা। তো এখনো ম্যাথমেটিক্সের লোকজন কাজ করে, কিন্তু আমাদের দেশে একটা মেন প্রবলেম কি হচ্ছে, যে এখন আমাদের যে কোভিড-19 নিয়ে আমরা যে কাজ করছি, কিছুদিন আগে ডক্টররা বলেছেন যে 49 ডেজ যদি অ্যাট এ টাইম আমরা লকডাউন করে দিই তাহলে আমাদের চেইন ব্রেকডাউন হবে, আমাদের সাকসেস হয়ে যাবে, আমরা কোভিড এর সাথে আমরা জিতে যাব। কিন্তু কেন হচ্ছে না, তার কারণ হচ্ছে দেখুন যে ম্যাথমেটিশিয়ানরা আমাদের ISI বলুন, তারপরে শিবপুর বলুন, এখানে প্রচুর আমাদের ম্যাথমেটিশিয়ান কাজ করছেন উইথ আদার গ্রুপস, কিন্তু ওই মডেলগুলোতে ম্যাথমেটিক্যাল মডেল সেগুলো হচ্ছে স্ট্যাটিস্টিক্যাল মডেল। তো সেই মডেলগুলোতে যে প্যারামিটার গুলো কনসিডার করা আছে, প্রচুর প্যারামিটার্স আছে, সেই প্যারামিটারের যে ভ্যালুস গুলো নেওয়া হচ্ছে সেই ভ্যালুস গুলো কিন্তু পারফেক্ট হচ্ছে না, মানে সেখানে ইনকারেক্ট প্যারামিটার্স এর ভ্যালু অ্যাসিউম করা হচ্ছে। কেন ইনকারেক্ট হচ্ছে? ম্যাথমেটিশিয়ানদের দৌড় কতটা, তারা ম্যাথমেটিক্যাল ফর্মুলেশন করে দিল, মানে মডেল বানিয়ে দিচ্ছে, কি কি পসিবল প্যারামিটার্স হবে, কোথায় সেই প্যারামিটার্স গুলো ইউজ হবে, কিভাবে হবে, মাল্টিপ্লাই হবে না ডিভিশন হবে না অ্যাডিশন হবে, সবকিছু ঠিক করে দিচ্ছে। কিন্তু প্রবলেম হচ্ছে এখানে আমাদের মেডিসিনের লোক চাই, অ্যাডমিনিস্ট্রেটর চাই, যারা ওই প্যারামিটারের ভ্যালু প্রপারলি ডিটারমিন করার জন্য আমাদেরকে সাজেস্ট করবে। মেডিসিন মানে মেডিকেল রিলেটেড প্রবলেম, অ্যাডমিনিস্ট্রেশন রিলেটেড প্রবলেম, সোশ্যাল ডিস্টেন্সিং, এই সমস্ত যে প্রবলেমস গুলো আছে সেগুলো কম্বাইন হচ্ছে না। তো সেইটা হচ্ছে আমাদের দেশে যে মাল্টি ডিসিপ্লিনারি রিসার্চের কথা বলা হচ্ছে, তো সেটা একটা বিশাল ল্যাগ থেকে যাচ্ছে, যে আমরা একসাথে কম্বাইনলি কাজ করছি না। ডাক্তাররা প্যারামিটারের ভ্যালু ডিটারমিন করতে ম্যাথমেটিশিয়ানদের সাথে একসাথে বসছে না, অ্যাডমিনিস্ট্রেটর একসাথে বসছে না, যার জন্য সেই গ্যাপ গুলো থাকছে। তাছাড়া তো আমরা নিজেরা মানুষ যারা আমরা আছি জেনারেল পার্সন, তারা তো আমরা মানছিও না। তো এই সমস্ত গ্যাপ থাকার জন্য ম্যাথমেটিক্যাল মডেলগুলো কিন্তু অ্যাকচুয়ালি প্রেডিক্ট করতে পারছে না বা সাকসেসফুলি বলতে পারছে না। তো যার জন্য আমরা বলছি সায়েন্স ফেলিয়ার। কিন্তু আমাদের হচ্ছে যে মাল্টি ডিসিপ্লিনারি যে কাজ করা, কম্বাইন্ডলি যে কাজ করা ডিফারেন্ট ডিসিপ্লিন, যেটা আমাদের অন্যান্য কান্ট্রিতে হয়ে থাকে, সেখানে ম্যাথমেটিক্স বলে ডিপার্টমেন্টে নেই, কেমিস্ট্রি বলে ডিপার্টমেন্টে নেই, কম্বাইন করে করে এক একটা ডিপার্টমেন্ট করছে, সেখানে ডিফারেন্ট ডিসিপ্লিনে থাকে। তো এইটা আমাদের একটা ড্রব্যাক, সেটা আমাদের ইউনিভার্সিটিতে আমরা স্টার্ট করতে পারি, বিভিন্ন ডিসিপ্লিনের লোকজন একসাথে কাজ করতে পারি, তারপরে করে আমরা ডেভেলপ করতে পারি। তো যাক, এটা আমাদের ছোট্ট একটা অবজারভেশন। তো
চেয়ারম্যান স্যার, আরেকজন ম্যাথমেটিশিয়ানকে আপনার পাশে দেখছি, প্রফেসর শঙ্কর কুমার রায়।
হ্যাঁ হ্যাঁ,
কিছু বলেন, অতি সংক্ষেপে কিছু বলেন।
Yes, I am here. Okay, I am giving the answer of Prasenjit. He already asking the question about the fairness of mathematics among the students. Yeah, Prasenjit, hello.
Yes, I'm hearing you.
Actually, what is the main problem of us? Basically, students are getting more fear on mathematics. The reason is like this. If you go to the KG level, and thereafter class 1, class 2, class 3, class 4, class 5, and so on, just to calculate the ratio of the students and teacher, it is really a big number. What the number was or is 20:1, but it is 60:1 or 120:1. Indeed, my wife is in school. She has a class of 120 students, only one teacher. It is very sensitive things. How to generate the concept of mathematics among the students? It is very difficult. And for that reason, from the KG level to onwards, the mathematics is more, students are facing more problem to get the actual calculation of mathematics. And this is a main fairness of mathematics among the students. According to my conception, I think it is the main problem. About the new education policy, what the central government suggested to us, I think if the student and teacher ratio is 20:1, and then the teachers will able to teach the mathematics in proper way, and the problem will be resolved. Another thing, actually, if you survey the knowledge on mathematics about the students, some people are interested in English, some students are interested in English, some students are interested in mathematics. We have to separate the group. And up to class 8, all are okay. And thereafter, we have to divide the group in which group will go in this side and which group will go in other side. In that way, I think students can get more interest among mathematics for a particular group and others group will go to the English and other directions for getting more interest. In that way, we can remove the fearness of the students about our mathematics.
Thank you, Professor Rai, thank you. Professor Acharya, we may continue the discussion, but the time is, we have already crossed 1.5 hour time limit.
Right.
So
Yes,
before
sure.
I request the chair, sorry, we can have the discussion in our Bhuta platform or in other platform, we can continue our discussion. I sincerely apologize. Please understand my limitation. And
Sure.
Professor Maiti, before I request the chairman said to conclude, let me make some comment. Like Professor Maiti, there are some messages in the chat box. I hope you'd be able to answer to them, and you have gone through it. Sorry. With due apology for my wrong pronunciation, what I was going to tell in the beginning, that when I was there in North Bengal University, there was a famous quote in the Department of Mathematics of my erstwhile university. It's something like that. Yatha Siksha Mayuran Jatha Sikha Mayuranam Naganam Manayo Yatha Tad Bhavat Vedanga Sastranam Ganitam Murdhani Sthitam. It means in English similar to plumage on the head of a peacock, gem or jewel on the head of a serpent, the subject mathematics occupying the highest prominent place at the top among all the Vedanga Shastras. I think that's the answer to, that could be an answer to.
That also encouraged me also. Thank you.
Yeah. So I always my colleagues from mathematics for their superiority. We always suffer from some inferiority complexes. And one more comment for the Professor Maiti. I was expecting something about the famous mathematician Euler, the famous Euler theorem or other. Because I had the opportunity to visit the graveyard of Leonard Euler when I was there in St. Petersburg. Anyway, that is very beautiful, mind-blowing lecture. I am personally enriched. I did not know how the term mathematics have come from the Greek origin. I envy your way of teaching, all the mathematicians, all my esteemed colleagues. And I must convey my deep sense of gratitude to the university, the Honorable Vice Chancellor, for his kind patronage, to the IT team, information technology team, particularly Mr. Sunil Mollik, for extending the support. And last but not the least, all my esteemed colleagues and dear participants, I am sure we all have been benefited out of this splendid lecture. And let us wait for the next lecture to be delivered by another colleague, Professor Kaushiki Dasgupta. I will duly inform you in this regard. And thank you very much for joining the program. May I now request Professor Madhumangal Pal to kindly conclude with his remark. Professor Pal, please.
Yes. So thank you for different question arranges from our colleagues or other members. Thanks to Professor Maiti for introducing what is mathematics, the very initial or beginning terms of the subject. And gradually he goes to the modern applications of mathematics. He highlighted very few application areas. About the total intention of mathematics, only 1% or below that is applied for the development of the society or the for other purposes of the society. So a lot of areas are there of the mathematics to applied in different social engineering, engineering, medical science, or other areas. So Professor Maiti has highlighted some application areas. So we can go for another lecture for the application of mathematics or the development, recent development or mathematics or the Vedic mathematics, what are the importance of Vedic mathematics. We can go for another lecture. So thank to the speaker and also the University Authority, Professor Ranjan Chakraborty, our Vice Chancellor, his lecture series, and also the team. And lastly, we thanks to our, we can say the coordinator, Professor Romeo Kumar Panda, for his kind present, dynamic action. He is organizing nicely, very nicely this program series for a long time. So thanks to all the members present now. So we can declare the session is end.
Thank you.
Professor Panda, can I declare the session is end?
Thank you all. We look forward to you on in the next lecture.
Thank you.
On deep sense of gratitude to Professor Madhubal Pal for kindly sharing the section. With this, let us conclude. Thank you very much.
Thank you.
Okay.